Hey everyone, this is Mrs. Slauson. I am another Algebra 1 teacher at Eagle Crest, and I will be joining Ms. Roseline in your video notes. So Ms. Roseline has already gone over with you a review of factoring and also a review of the zero product property. So what we're going to be doing today is putting factoring and the zero product property together when we are solving these quadratic equations. So when can you use factoring to solve? You can use factoring to solve a couple things. First, your equation needs to be in standard form. And so standard form should be the highest power first, your x squared, then your x term, and then your constant term. And then the other thing that needs to happen is it should be equaling 0. So I forgot to write standard form. So you want it to look like that. So for instance, the first two problems are in standard form. It goes x squared, there is no x term, then I have my constant and it equals 0. In the second one, there's the x squared term, the x term, there's no constant, but it equals 0. When we get to problem 3 and 4, these aren't in standard form. So what I'm going to have to do is move the 50 over, and I'll do that by subtracting 50. So I'll subtract 50 from the left side, that'll cancel it out, so it actually equals 0 now. And then I'll be subtracting 50 from the left side, and that means my equation will look like x squared plus 5x minus 50 equals 0. And so I'm going to do the same thing with number 4. So on number 4, when people want to move stuff over, you want to make sure that your leading term, the x squared term, the coefficient, the number in front of it is always positive, because that's how we're teaching you how to factor. So I don't like the fact that this x squared is a negative 2x squared, so I'm going to be moving this to the other side through addition so it becomes positive. So when I move it to the other side, so I'm going to add 2x squared on the right side, add 2x squared on the left side. On the right side, they cancel out, so now it equals 0, and my left side in standard form is the x squared term, then the x term, and then the constant. So from there, we're going to start factoring. So the next question she asks is, how do I use factoring to solve a quadratic equation? Well, first, you're going to need to factor, and you're going to have to remember what Ms. Roseline taught you. And then what you want to do is take each of your factors, set them equal to 0, and solve. So isolate for x. So we're going to run through the different ways to factor. So number 1, if you notice, is a difference of squares. It's a difference of squares because there is subtraction between the two terms, and each term has a perfect square root to it. So the square root of x squared is x, the square root of 49 is 7. I can make my factors now into x plus 7 and x minus 7. So we factored it, so it's now in factored form. And then again, what Ms. Roseline showed you, we can use the zero product property. So I can take my first factor and set it equal to 0. And I'll take my other factor, set it equal to 0, and then solve for x. So in the first one, it's pretty simple. Just subtract 7 from the left side, subtract 7 from the right side. On the left side, you're left with x, and on the right side, you now have negative 7. When you do the next problem, I'll just be adding 7 on both sides. The 7s will cancel out on the left side, so I'm just left with x, and now it will equal 7. So we've got our two answers, 7 and negative 7. Number 2, the first thing I'm going to attempt is a GCF, a greatest common factor. And what I notice is in this problem, I can factor an x out of both terms. So I'm going to do that. And I want to ask myself, x times what makes 2x squared? And that's 2x. And there's the plus sign. X times what gives you that 3x? And that's 3. And now this is factored completely. And now I'm going to take each factor and set it equal to 0. So I'll take this factor, set it equal to 0. I'll take this factor and set it equal to 0. And then I'll solve. So the nice thing about the first one is it's actually solved. There's one of our solutions, x equals 0. On the other one, to get x alone, I'm going to subtract 3. Those 3's cancel out. I'm left with 2x on the left side, negative 3 on the right side. And now to solve for x, I'll divide by 2 on both sides. And I will be leaving my answer as a fraction, because when you do your Go formative assignment in just a little bit, your answer will be asked to be as a fraction, not as a decimal. All right, number 3, now that it's in standard form, the first thing I want to again look for is a GCF. I don't see one, but since there's 3 terms, I'll be making my x. So I need factors of negative 50 x squared that get me to this 5x. And those factors are going to be 10x and 5x, and we're going to want to make the 5x negative. And now what we're going to do is we're going to rewrite this. So 5x is going to split up into these 2 terms here. So the circle's replaced by the circled. So I'll start rewriting x squared, and 5x is split up into these 2 terms right here. So plus 10x minus 5x, and then I'll resume with the minus 50 equals 0. And now that I have the 4 terms, I can group them. So parentheses on the first set, parentheses on the second set, and now I'll just GCF my first set of parentheses. So I'll be able to factor an x out of both of those. And when I do that, from the x squared, I'm left with x. And from the 10x, I'm left with 10. And remember, when you GCF the second set of parentheses, we're going to have a matching set of x plus 10. And so that's going to force me to take out a certain GCF out of here, and that will be a negative 5, because negative 5 with x is this negative 5x, and negative 5 with the 10 would result in the subtracting 50. So now I have my 2 factors, x minus 5 and x plus 10. And I'm just going to set each factor equal to 0. So here's x minus 5 equaling 0. X plus 10 equaling 0. And now to solve for x, on the left one, I'll add 5. And when I'm done, I have x equals 5. And on the other one, I'll subtract 10. And when I'm done, I have my other answer of negative 10. All right, last problem, probably the toughest one. So first, I'm going to look for a GCF. I do not see one, but since there's 3 terms, I'll be making my x. So I need factors of 6x squared that will get me to the 7x here. And those factors are going to be 6x and 1x, both of them positive. And now I'm going to replace the 7x with these 2 terms, which give you 7x. So I'm going to rewrite the equation now. It's going to be 2x squared, but instead of the 7x, I'll be putting this in there. 6x plus 1x, and then I still have the 3. And now that I've got the 4 terms, I can group the first 2 and the last 2, and now I'm going to start with my GCF. So in the first set of parentheses, not only can I factor out an x, but I can also factor out a 2. And then when I factor a 2x out of the 2x squared, I'm left with x, because when you multiply those, you get the 2x squared. And then from the 6x, I'm left with a 3. If you multiply these, you get the 6x. I'll be making my matching set of parentheses on the other one. And that will force me, when I GCF the second set of parentheses, to have taken out a 1, because 1 times x is this 1x, and 1 times 3 is this 3. All right, we got our 2 sets of factors now. So one of them is 2x plus 1, because that was a positive 1, and x plus 3. And now I'm going to set each factor equal to 0. I'm going to solve the one on the right first, because it's the easier one. I'm going to subtract 3. So one answer is x is negative 3. And on the other one, I'm going to subtract 1. Those 1's cancel out. I get 2x equals negative 1. And now to solve for x, I'll divide by 2 on both sides. And when I'm done, my other answer is negative 1/2. Again, on the Go formative assignment that you're about to complete, you'll be leaving this as a fraction. You will not be turning this into a decimal. And that's it. We'll talk soon.